Hi, my name is Talia Nasi, and I'm a Senior Developer Advocate here at AWS Serverless. Two options when building web applications are request response and event-driven architecture. In request response architecture, an application's components communicate via API calls. The client sends a request and expects a response before performing the next task. In event-driven architecture, the client generates an event and can immediately move on to its next task. Different parts of the application then respond to the event as needed. When starting to build a new application, many developers default to a request response architecture. A request response architecture tightly integrates components, and those components communicate via synchronous calls. While a request response approach is easier to get started with, it can quickly become challenging as your application grows in complexity. In a typical e-commerce application that uses a synchronous API, the client makes a request to place an order, and the order service sends the request downstream to an invoice service. If successful, the order responds with a success message, confirmation number, etc. And in this initial stage, this is a straightforward connection between the two services. The challenge comes when you add more services that integrate with the order service. If you add a fulfillment service and a forecasting service, the order service has more responsibilities and more complexity. The order service must know how to call each service's API, from the API call structure to the API's retry semantics. If there are any backwards incompatible changes to the APIs, the order service team must update them. The system forwards heavy traffic spikes to the order service's dependency, which may not have the same scaling capabilities. Also, dependent services transmit errors back up the stack to the client. Now you add new downstream services for fulfillment and shipping orders to the e-commerce application. In the happy path, everything works as expected. The order service triggers invoicing, payment systems, and updates forecasting. Once payment clears, this triggers the fulfillment and packing of the order, and then you inform the shipping service to request tracking information. However, what happens if the fulfillment center cannot find the product because they are out of stock? Fulfillment might have to alert the invoice service, then reverse the payment or issue a refund. Would the system trigger shipping if fulfillment fails? Maybe not, since it's directly before shipping in the chain of events. Forecasting will also need to be updated to reflect this change. This remediation workflow is all just to fix one of the many potential unhappy paths that can occur in a synchronous API-driven e-commerce application. In a synchronously integrated application, teams need to coordinate any new services that are added to the application. This can slow down each development team's ability to release new features. Imagine your team works on the payment service, but you weren't told that another team added a new service, a reward service. What now happens when the fulfillment service errors? Fulfillment maybe orchestrates all of the other services. Your payment team gets a message and you undo the payment, but you don't know who handles retries and error logic. What happens if the reward service changes vendors and has a new API? Did your team know about that? Ultimately, it's very hard to coordinate these orchestrations and workflows as systems become more and more complex, and as you add more services. Event-driven architecture can help solve the problems of the close coordination of microservices, error handling and retries, and coordination between development teams. In event-driven architecture, the publisher emits an event which is acknowledged by the event bus. The event bus routes events to subscribers, which process events with self-contained business logic. There is no direct communication between publishers and subscribers. Decoupled applications enable teams to act more independently, which increases their velocity. For example, with an API-based integration, if my team wants to know about some change that happened in another team's microservice, I have to ask that team to make an API call to my service. That means I have to deal with authentication, coordination with the other team over the structure of the API call, etc. This causes a lot of back and forth between teams, which slows down development time. With an event-driven application, I can simply subscribe to events sent from your microservice, and the event router, like Amazon EventBridge, takes care of routing the event, handling authentication, etc. Another reason to migrate to event-driven architecture is to be able to handle unpredictable traffic. E-commerce websites like Amazon.com have variable amounts of traffic depending on the day. Once you place an order, a bunch of things happen. First, Amazon checks your credit card to make sure you can pay. Then Amazon has to get the merchandise off the shelves and onto the trucks, and so on and so on. That all happens in an Amazon warehouse. There's no synchronous API call for the Amazon backends to package and ship products. After the system confirms your payment, the front end puts together some information describing the event and puts your account number, credit card info, and what you bought in a packaged event and puts it into the cloud and onto a queue. Later, another piece of software will pull it off and start the packing, shipping, etc. The key point about this process is that all of these things can run at different rates. Normally, the rate at which people click place order and the rate at which warehouses can get the boxes out of the doors are roughly equivalent. However, on days like Prime Day or Black Friday, people hit that button immensely faster than the warehouses can operate, and that's okay because the back end will work itself through. E-commerce applications like Amazon.com need to be able to scale up to handle unpredictable traffic. When a customer places an order, an event router like Amazon EventBridge receives the event, and all of the downstream microservices are able to pick up the order event for processing. Because each of the microservices can fail independently, there are no single points of failure. Event-driven architectures promote development team independence due to loose coupling between publishers and subscribers. Applications are free to subscribe to events with routing requirements and business logic that are separate from the publisher and other subscribers. This allows publishers and subscribers to change independently of each other, providing more flexibility to the overall architecture. Decoupled applications also allow you to build new features faster. Adding new features or extending existing ones is much simpler with event-driven architectures because all you have to do is choose the event you need to trigger your new feature and then subscribe to it. There's no need to modify any of your existing services to add new functionality. To learn more about event-driven architecture and Amazon EventBridge, head to serverlessland.com, where you'll find more content from me and my team. I'm Talia Nasi. Thanks for tuning in.